So, good morning, one and all. Today, we have discussed about the reinforced earth retaining walls. That, so we're talking about the soil nailings. The soil nailing is a ground stabilization technique that can be used on either natural or excavated slopes. So, in so many places, it has used for the proposed and already existing structures. So it involves drilling of holes by steel bars to be inserted into a slope face, which are then grouted in place. Mesh is attached to the bar ends to hold the slope face in position. So we have some pictures also, so you will understood what the position of slope after the bars are inserted. The soil nailing is a construction technique that we used to reinforce soil to make it more stable, so improve the properties of the soil, bearing capacity, displacement, so many in so many cases. So we have to use the soil nailing. We use this technique for slopes, excavations, retaining walls, etc. to make it more stable. In this technique, soil is reinforced with slender elements such as reinforcing bars, which are called nails. This technique is a technique to reinforce and strengthen the ground adjacent to an excavation by installing closely spaced steel bars called nails as construction proceed from top to bottom or top to down. See here, the existing the structure will be there. So they have to insert it the soil nails. These rods are called nails top to bottom. The first one, second one, third one, and fourth one to improve the property of this portion of the soil. It is an effective and economical method of constructing retaining wall for excavation, support of hill cuts, bridge abutments, and highways. The nails are subjected to tension, compression, shear, and bending moments. So these are some images where the soil nailing technique has to be applied. See, these are the rods are inserted into the slope face, and this will be the machine. So it inserted the nails rods, that is called as the nails. This is also a picture that the construction procedure will be the construction will be in the progress. And here the components, here the reinforcement steel plates at the facing surface, in the soil mass, the slides zone, bulk outline, latex membrane, nail rod, so that will be inserted into the soil mass. So these are the applications where we have used the soil nailings. See here the abutment, the flyovers, retaining walls. So what is the concept here? What is the concept behind this technique? The function of soil nailing is to strengthen or stabilize the existing steep slopes and excavations as construction proceeds from top to bottom. Soil nails develops their reinforcing action through soil nail interaction due to the ground and deformation, which results in development of tensile forces in soil nail. The major part of resistances comes from development of axial force, which is basically a tension force. So always, so it will be inserted when the soil is weak in tension. So that's why the tension rods will be inserted to avoid the displacement. So what are the advantages here? The good and confined spaces with the restricted access, less environmental impact, relatively quick and easy to install. So if the equipments are easily available, use less materials and shoring, flexible enough to be used on new constructions, temporary structures, or on remodeling processes. The height is not restricted here. There whatever may be the height, In the reinforced earth, the new work will be, it's very difficult to process at the height. So, but here, that there is the equipments, you have to go with the limited. There is no limit to the height. The limitations here, they are not suitable for areas with a high water table. So where the water table will be high, so it's not suitable. In soils of low shear strength, very high soil nail density may be required. They are not suitable for permanent use in sensitive and expansive soils. Specialist contractors are required. Very well experienced contractors will be required. So where their experience will be in the soil nailing. Extensive 3D modeling may be required. So we have to make the model. Before that, we have to make the software model to know what the length, what the depth will be required for that. So thank you. In the next session, we will study the more thing. Thank you.